I'm just going to do some of the problems from the 6.1 homework. I don't know exactly if I want to do like all the evens or all the odds, so I'll just kind of see what I do and go from there. I think I would like to do number 2. So number 2 gives you the measure of angle B. It's 89 degrees. The measure of angle A is 61 degrees, and side C is 16 centimeters, and then it asks us to find the side length B. So that's what we need to be finding, right? Okay, so if I were to think about like angle and side pairs as far as law of sines go, it looks like the only side length I'm given is C, which means I need angle C, and that's okay because even though they don't specifically state it, it is given by giving me A and B, because I know that 3 angles have to add up to 180. So that's 89, 90, so 150. So those two added together is 150, so 180 minus 150 is 30. So I've got an angle and a side pair. So here's what I know. I'm trying to find B, so I'm going to start with that. I always start with the variable that I want. It's a side length, so I don't have to put sine of it. So divided by sine of angle B, which is 89. And then side length and angle, so 16 over sine of 30 degrees. So if I'm trying to solve for B, then I'm going to multiply by sine of 89 on both sides. And you don't have to show the step, but... And then we just type it in, and we get our answer. Make sure you're in degree mode. And you switch for calculus. So then 16 sine of 89 divided by sine of 30. 16 sine of 89 divided by sine of 30. And that gives me 31.995. So 31.995. And it looks like B was measured in centimeters, so we'll go ahead and measure, or C was measured in centimeters, so this will be in centimeters as well. And just remember that I like 3 decimals as far as how many places you're supposed to go. Okay, so let's go to number, I'm going to go to number 5. Okay, so on number 5 we were given the measure of angle C. It's 151 degrees. Side B is 10 yards, and side C is 40 yards. And then the question is, what is the measure of angle B? Okay, so angle and a side length, we do have an angle and a side pair C, and we're trying to find angle B. So I always start with the thing I want. Capital B is the angle, but it's not, you don't just leave an angle naked, you have to take the sine of it. Okay, so in the formula, it's sine of the angle divided by the side length, 10, equals sine of the angle over the side length, 40. So in this case, what we're going to do is we're going to do a couple steps. First, in order to solve for angle B, you're going to multiply by 10. And then, in order to undo the sine, you're going to take the sine inverse. So sine inverse of... You can leave the 10 up there and say 10 sine of 151 over 40, or you could simplify 10 and 40 and say 1/4. And so it just ends up being sine of 151 degrees over 4. And that's what I'll type in. So, okay, sine inverse of sine of 151 divided by 4. 6.962. 6.962. And remember that this 6.962, this is an angle, so that's measured in degrees. You got to make sure that you give the measurement of the unit, okay? Now, let's talk about the feasibility of this, yeah? Okay? We didn't really talk about the feasibility in number 2. We just kind of went with it. I'm going to go ahead and talk about it right here, though. Okay. So I've got an angle C that's 151 degrees. So this is 90. 151 is like right in here, yeah? So I've got a triangle where this angle is 151, and that is angle C. Then I've got B being 10 yards, so we're going to say this is 10. And then we've got this being 40 yards. So this is 4 times the length, so maybe something like that. Yeah? So we'll say that's 40 yards. And then the question is, if this is side B, then what's angle B? So it makes sense that angle B has to be very small in order for this to make sense, okay? So our answer is feasible. Remember that the largest angle should have the largest side, okay? And the smallest angle should have the smallest side length. Not that we found the others, because we're just solving for the one unit that they're asking us to solve for. But if you do solve for the others, then that needs to make sense. Okay. And just as a thought process, if I tell you that you have an angle, right? And say I tell you that I have what if I tell you that you have like a 29-degree angle, and I tell you that that's angle A, and then I tell you that this side length is 10, and this side length is well, I guess I can't really say that you have a smaller one without giving it all to you. I can give it all to you though. Okay. So if I tell you this angle is 29, and then I tell you this angle is, let's go 92, right? And this angle is B. And so this is side C. And so then this would be what? 92 plus 29, so it's 110, 121. So 30, so 120, yeah. Oh, wow, that's 180 minus 121. 180 minus 121 would be 59. Yeah? So that's 70, 88. Yes, okay. So this is side C. So say I said side C is 10, and then I said side A, no, yeah, sorry. This whole premise is me based on, like, trying to figure out how you could determine whether or not something is feasible or not. And I guess what I was trying to do was show you that, like, if I gave you the smallest angle, but then it had a larger side than something else, then you would say, well, that doesn't make sense. The largest angle has to correlate to the largest side, and the smallest angle has to correlate to the smallest side. That's across from it. But in the example I'm giving, that doesn't make sense, because I'd have to give you everything, in which case you wouldn't be solving for anything. Okay. I am going to talk about number... I'm going to talk about number 9. Okay. So number 9 gives me that angle A is 55 degrees. C is 29 feet, and A is 26 feet, and then it's saying find the measure of angle B. Okay, so I'm going to draw the angle that I'm given. 90 degrees would be straight up, so 45 is halfway, 55 would be in here somewhere. Okay, so I'm going to let that be angle A. They're telling me that I've got two side lengths, C and A. So A cannot be, A has to be across from the angle, right? So it has to be this side length, wherever it is. So I'm going to let this be C, 29. And so first off, let's talk about lengths possible, right? Because this is a situation where I could have more than one. I guess I didn't address, let me see. Is that something I should have addressed? No, 5 was an obtuse angle, so that's definitely out. Because it's only the whole multiple cases only works out if you have an acute angle. And 2 was 89. Oh yeah, I was was given two angles, not just one angle and two sides. Okay. So in this case, given an angle and two sides, the question is, do we have 0, 1, 2, 0, 1, or 2 triangles? So I'm gonna just draw a couple things. Just a reminder. Here's the height, right? I don't know what it is, but I'll figure it out in a second. If my side length is shorter than the height, so if A is shorter than what the height is going to have to be, so say it like comes down but it doesn't quite reach, then we have 0 triangles, right? If A is the exact same length as the height, then I have exactly 1 triangle, and it's the right triangle. If A is a length that is longer than the height, this length, but shorter than this, then it could be the one with 2 different options, because it could be here or it could be here. Then we have the 2 different options, right? And then also, if I ran out of colors. Okay, if it is the same length as this right here, which we know it's not, right? They're not the same. Then that would be an isosceles 1 triangle, and if it's longer, anything longer would be out here, and that could only create the 1 triangle. This, and then way over here, and then there. So the first thing we need to do is, or the main thing you need to do is determine the height. Okay. So my height is the length from the top of the triangle to that horizontal. And I know that sine of 55 equals height over 29. So I'm going to multiply by 29 and say 29 times sine of 55. And I get 23.755. So this height is 23.755 feet. So when I think about this length right here, 26, 29 and 23.755, 26 is between those two, which means 26 could be in here, or it could be over here. So this is one of those situations where I'm actually going to have 2 different measures of angle B, because angle B could be this angle right here, or it could be this angle right here. It kind of depends on, well, you'd have to be given something else. You'd have to be given an angle or a side length, any of the other information, okay? So as it is, what I'm going to do is I'm going to erase this and draw 2 different triangles with the same information. Okay. So I've got the 55-degree angle and the 26 wedged in. So swung this way. So 55-degree angle for A. This is going to be B. I'll go ahead and say B2 because we're going to find it second. And then we're going to let this be C. Oh, interesting. Just kidding. I totally labeled the B wrong on the image. B is up here. So we're talking about the difference between this angle and the other one. This is angle C. Oops. Okay. So C is 29 and A is 26. Okay. And then we've also got this. So it's longer than the height, but shorter than that side. So this is angle A, 55, 26, 29. If you can hear that thud, that's my C1. My dog jumping on my back door. Okay, C1 and B1. Okay, so these are my 2 answers that I need, okay? And the way that I'm going to figure those out is by figuring out angle C. So angle in a side pair, I'm going to do angle, well, what do I want? I know it's always going to solve for the acute angle first, so I'm going to do C first. So sine of C1 over 29 equals sine of 55, angle A, over side A, 26. So I'm going to multiply by 29 and take a sine inverse. So sine inverse of 29 times sine of 55 divided by 26. Make sure you close your parentheses after your sine, okay? And I get 66.017. So angle C1 is 66.017. So when I think about what is the measure of angle B1, all I gotta do is add those up and subtract from 180. So plus 55, and then 180 minus my answer. And I get 58.983. 58.983. So 58.983 degrees is the measure of angle B1. So this B. And now we gotta find this B over here, right? So we gotta remember that in our two triangles, right? I'm gonna remind you of this image real quick. Whatever this angle is, this is the same. Because this is an isosceles triangle, they're the same length, so just swung one way or the other. So whatever this angle is, that's the same. That means that is just 180 minus this one, okay? Because they're supplementary. They make these two make a linear pair, but you can say they're supplementary. So we're going to say 180 minus the 66.017, and we get 113.983. So this right here is 113.983. That means angle C2 is 113.983. Okay. Well, once I have that, then all I have to do is do 180 minus those two, and I can solve for B2, angle B2 anyway. So angle B2 equals that plus 55 and 180 minus that. And that would be 11.017. So as far as my answers go, you've got two. You've got 11.017 for one of the angles and 59.983 for the other angle. And there we go. Those two different angle B's. That was very important. I was just like going with what I assumed it would be, and I thought it was going to be that angle, but it's angle B. Okay. All right. Let's do number I'm going to do number 13 together with you. I do want to say, though, your directions when they say just solve the triangle, let's remember you're supposed to solve all the other things. In this one I have angle A, B, and C. I have two of the side lanes. I would need to do the law of sines one more time to solve for the side B if I wanted to. So I would put a sine of angle, well, I would put B over sine of angle B equals 26 over sine of 55, and then solve for that. And then I would do the same thing over here. But as far as like being able to figure it out, it's a good idea to have your images drawn, two different triangles, if you need to use another piece of paper for that. If you're printing it off. If you're not, then you're using your brown paper anyway. Okay. So like I said, number 13. It says in triangle FDE, the measure of angle F equals 97 degrees, E equals 9, and F equals 22. So, okay. 97 degrees, here's 90, 97, somewhere in here. Oh my gosh. Okay. And, let's see, side F is 22. Let's see, I'm going to make this, try to make as much sense. Okay, so I'm going to let this be 22. They didn't give me any units, did they? No. And so that's little f, and then side E is going to be 9, so I'm going to let that be 9, which makes this angle E. And it says FDE, so that's going to be angle D and side D. Okay, we're going to do, you know, whenever the angle is obtuse, I don't have to worry about my two different situations as far as the triangle goes, because it can only swing out past this. Now, I will say this. What if I had said this is 97, this is 9, and then this is 8? Well, I'm going to exaggerate because I don't want to go over my 97. Oh, who cares? Okay, if it had been 8, then it would have been too short to reach this right here in order to go past the horizontal, like past the vertical. So whenever you have that angle, you're supposed to reach. So if this is 97, it should have the largest side. So if this side is larger than that side across from the largest angle, then that, I would just say not possible. They're triangle not formed, something like that. So 97. Okay. We're going to do law of sines with their angle and side pairs. I'm trying to solve for, first, let's go with an angle. Let's go with angle E. So we're trying to solve for angle E. Okay. So I always start with what I want. If it's an angle, I've got to put sine of it divided by side E. It keeps looking like a C. Okay, so angle E over side E equals angle F, sine of angle F anyway, over side F. And then we're going to multiply by 9 and take the sine inverse. So sine inverse of 9 times sine of 97 divided by 22. And that is 23.956. 23.956. So we'll let angle E be 23.956 degrees. Okay. So if I know that angle and I know that angle, then I need to figure out angle D. So plus 97, and then 180 minus that. So 59.044. 59.044 degrees is that one. Okay, and so I'm going to list this out real quick. So angle E is 23.956 degrees. Angle D is 59.044 degrees, and the only other thing we need to find out is side D. Okay, so we want a side length, we've got its angle, so we're going to use the angle in a side pair, but this time we're going to start with the side length on top, because that's the variable I want, divided by sine of 59.044 equals, and then we're going to use the angle and side pair. I have a side on top, so I need side on top, 22, divided by sine of the angle, 97. Okay, so we're going to multiply by sine of 59.044, so 22 times the sine of 59 times sine of 59.044 divided by sine of 97, 19.008. So 19.008. And let's see if that makes sense. Largest side goes with largest angle. This is the next largest angle, and that's 19, and that's 9 with the smallest angle, so that does make sense. Okay, so that is number 13. And then I want to do state but do not solve the number of possible triangles that can be formed. Okay. I'm going to go with number 18. Okay. Number 18 says, in triangle TRS, angle T is 57 degrees, S equals 32, and T equals 30. Okay. So 57 degrees, somewhere in here. That's an acute angle, and anytime you're given an angle and two sides, right, then you have that situation where you can have more than one. Okay, S is the other side length, so we're going to put 32, and then 30, okay, is the side length of T. So I'm just going to, well, I'm going to do a couple things. I'm going to remind you of just like some, if you wanted to write out the criteria for each. We need to find the height, obviously, because if it's too short, then we don't even have a triangle. So sine of 57 degrees equals height over 32, or 32 times sine of 57. and that is 26.837. So 26.837. So in the context of these numbers, I want to talk about your different options, okay? So you have 0 triangles if side T, which we know is 30, right? But I'm just going to kind of play around, pretend like I didn't know. If side T is shorter than the height, so it's less than 26.837. You have 1 triangle if T equals 26.837. If it is the height, then that's just, you got the 1 triangle. If T is greater than 26.837, but less than 32, so if it lands anywhere in between these 2 lengths, right, then it can be something here that could swing over here or there and still use this angle. Then you've got 2 triangles. Okay? Okay, so what if you're not between these 2? The next option is you're exactly the same as 32, or you're more. So you would again have only 1 triangle if T is greater than or equal to 32. Okay? So those are your options. In our case, 30, T equals 30, lands in between these 2, which would mean this would be 2 triangles. And my work would be, besides showing my height, is I would probably say that statement right there. T is less than 32, but greater than 26.837. Okay? Alright. That was number 18. Let's go to... oh yes, the bookwork. I have a book underneath. Another one sitting around, but I don't. Okay. I'm gonna grab, it's gonna take me a second, I'm gonna grab the book out from underneath the computer. So, ugh. Okay. Page 721. And it says numbers 47 through 49. So 47 through 49. And 52, 54, 55, 52, 54, and 55. Interesting. Okay. I think I'm gonna do, let's see. These are all pretty straightforward. I think I'm just gonna do 55, and then I'll answer questions as you have them. Okay. So 55 says, when the angle of elevation of the sun is 62 degrees. A telephone pole that is tilted at an angle of 8 degrees directly away from the sun. Cast a shadow 20 feet long. Determine the length of the pole to the nearest tenth of a foot. Okay. So, and it does have the answer there, which is kind of nice. But I'm going to go ahead and work it. Okay. So I'm going to zoom me back out on my marker board. Okay, with an angle of elevation. Okay. 62 degrees, so we've got the light pole, and this angle is 8 degrees. It's terrible. And we're supposed to find the length of the pole. This being 62 degrees, and these two being 20 feet apart. So we're trying to find this length right here. Let me go with a different color. Okay. I'm going to label that X, and I'm going to talk about what else do we know. If I know this is 8 degrees, and this right here is a right angle, right? If I take away the 8, then that means this is 82 degrees right here. Okay? You've got the right angle, take away 8, and you're left with the interior angle of this triangle. So this is 82 degrees. Okay, so if I know this is 82 and this is 62, then that's 144, which leaves this to be 36 degrees. Right? Yeah. So then I have an angle and a side pair, and then I have an angle and I have this side that I want, right? So I'm going to start with the x that I want, x over. And x goes with, it's a side length, so divided by the sine of 62 equals side length, 20 over sine of 36. We multiply by sine of 62. I'm trying to grab my phone to do that. So 20 times sine of 62 divided by sine of 36. And to the nearest tenth, we get 30.0. So 30.0 feet tall. Okay. And that is number 55. No. Yeah, 55. And I will be more than happy to answer any of the questions individually over the stuff that you have. Please do remember to send me a picture of the problem as you have it, because like when you guys just randomly ask me, hey, can you help me with this problem or this problem, if I don't have the problems in front of me, like I want to be able to answer it no matter where I'm sitting, or no matter where I am. Just send me a picture of the problem along with your work if you have any, or not, because then I can just work from there, okay? Alright.